Hello, hello. All right. So as mentioned throughout the last couple of weeks, we are using an architectural design pattern, the model view controller design pattern, and it's a design pattern that has been fairly successful in implementing for large scale web applications. The MVC, right, as the name suggests, it stands for model, view, controller. All right, and it's one of many design patterns. If you're familiar with design patterns at all, it's basically the collective discovery through in an engineering field of best practices that folks have been identifying as they have tackled certain well-defined problems, right? And as they have tackled them many, many times over history, they identify things to do and things not to do, right? And they codify them, they document them, they write them down for posterity, so that folks, other engineers that come later on, they can read through these design patterns and say, faced with this type of problem, there are these types of solutions. Okay, so once you tackle many certain problems over and over, you identify patterns, right? And so folks in different fields, write down these patterns so that folks later on don't have to reinvent these things later on, right? So they should look at the literature and say, this problem, this solution. And say, well, this is where it works well, this is where it doesn't work well, these are some of the assumptions and whatnot. There's also anti-patterns, things that are known not to work as well. It says, these are the things that you should do, these are definitely the things you should not do. One of those design patterns, there's tons of them, there's books and books on design patterns, and not only in computer science, obviously in many other fields as well, in chemical engineering, mechanical engineering, civil engineering, each industrial field has its own design patterns, okay? So in computer science, there's a body of accepted or well-known design patterns. One of them is model view controller. And what model view controller stipulates is that it works well to break up large applications into three distinct buckets. Right? Three buckets where you might have the view, the control, and the model, where you might have here the end user interacting directly with the view. The view being the first thing that the user sees, right? Typically a user interface. It doesn't have to be graphical. It could be also textual, whatnot. Yes, and so as the user interacts with the view by typing, clicking, dragging, the view generates a stream of events that are handled by a controller, right? The controller having the responsibility of interpreting these events and then causing some effect. Typically, the controller would then dispatch or delegate the actual action of removing a course or adding a course or editing something, right? It delegates it to someone who's responsible of manipulating the data. So here's your data structures, your arrays, your objects, and then this is manipulated by either removing or adding or updating something in that model, and then eventually this model is being sent over to the view by the controller for the view to render that data. Okay, and this has worked very well in large web applications. In smaller web applications, it might be an overkill, an over design. Okay, and certainly we've been we've been using this design pattern in our assignments and here in class. And as we go forward, we'll be applying it more and more. For what we've been doing, just logging in and registering and creating users, it's an overkill. It's a very small little piece of an application. But as it grows, right? It'll be much more apparent that it's a very useful design pattern. This is an architectural design pattern, meaning it has decision across a large application, how to break up many different parts of the application. It's also based on a smaller version of another design pattern. It's called a division of concern, right? Meaning we want to be able to break up our application based on the different concerns that you might have, right? And try to solve those concerns and try to divide and conquer, kind of, right? Where the view will have the concern of displaying content for the user. That should be its only concern, right? It has no idea what the structure of the data looks like, whether you're using array lists or linked lists or whatever the structure you decide over here. It should not matter, right? It should not be the concern of the view, right? And vice versa. The model should do its concerns is to structure the data, normalize it, make sure that you don't have any redundancies, that you don't have any inconsistency in the data, that it has performance of being able to retrieve data and store it and whatnot. That's its concern. It has no concerns on how eventually it's going to be rendered. Okay, so it should not care about colors and fonts and any of that, right, or layout, right? Well, unless that is the data. Okay, and same thing here. The view shouldn't care about database dependencies and whatnot. Okay, and the controller kind of sits in the middle. That does look like a traffic cop that says, oh, I know who to send this particular event to handle this. Always because there's a little bit of disconnect between these two worlds, the model world and the view world. Right? The model world, it might decide that the data is best organized into multiple tables, and then you have to join them to retrieve the data. Whereas the view, it doesn't really care how you split it up and whatnot. It might want to consume the data as if it were one big worksheet, one big Excel spreadsheet. That might be the way that I want to consume the data over here, right? So oftentimes the controller kind of negotiates, right, of this relationship of how you want to view things, or how you want to store these things. Okay, like for instance, over here you might have X, Y, Z, 1, 2, 3. And this could be rendered here either as a pie chart, right? 1, 2, and 3, or it could be rendered, as a bar chart, right? The same exact data, but rendered in two different ways. Yes. So the view is concerned on how to lay this out, how to look pretty, the fonts and whatnot. The model doesn't care about that, right? Its only concern is to store this correctly. All right, so that's the idea behind a model view controller. How does it instantiate, or how does it concern us, right? So we've been kind of following that. Yes.
Between the controller and the model, who is responsible for maintaining certain database invariants? Like, say, in our class exam, in the assignment 1, we were supposed to have that no two users have the same username.
Mm-hmm.
But that's not something that the server model was set to maintain, and that instead we had to use the controller to check for usernames and not allow registration.
Well, no, it's so typically you want to validate as often as possible and as early as possible. Okay, so in our particular case, the controller running on a browser is too ignorant to know whether a username already exists. Right, it needs to ask the database. Right, it needs to ask the database, does this username already exist? Right, but we're trying to do it as early as possible, meaning we're trying to let the user know, hey, this username is already taken, so that we could just let it go through and have the server handle this, right? And the database will complain, saying, well, no, that username needs to be unique, and you get an error, right? And so that would be way too late to validate something, right? Let it fail at the database, right? So you can spread out that concern across multiple layers, right? You can have it at the front end, but it needs to go out to the server, or you could let it as late as possible on the server. Typically, you want to do it as early as possible and as often as possible. So if you validate on the client, you validate on the server again, and then you validate later. You also validate on the database. For instance, one of the constraints that we might have added to the database is that the username should have been unique. We haven't, but that could be a good constraint to add, right? And then you might say, well, if I added that uniqueness on the database, why even bother in the client side? Well, because it's a better user experience, right? To keep the user informed of any and try to avoid even running into that issue. But nevertheless, somebody might create another user interface that doesn't do any validation, right? So you always want to make sure that even in the server, even in the database, you do the validation, even though presumably you've created several layers of validation before you even get to database, right? So that should never ever happen, but nevertheless you've validated and enforced that constraint all across the entire stack. I don't know. Did that answer?
Yeah.
Okay.
I was just wondering because of our implementation not having the server.
Yeah. No. It should be at every step of the infrastructure, the lowest of the stack. All right. So what we've been doing, applying the model view controller. This is a design pattern that has been around for forever, for decades. Right? It has been been very, very successful up to this point in all the types of web applications that have been around for a couple of decades. It used to have the following pattern. It used to have that you have a browser here, and on that browser, the queries might go to a server side, right? And on the server, you would ask for documents that rendered content on the server side, right? Using technologies such as either ASP, X, or JSP, or PHP, or any of several server-side rendering technologies, right? These technologies would have HTML alongside embedded executable code, right? Either basic, Visual Basic, or it might have if you go way back and you might even have C, or you might have Java, or you might have PHP embedded inside of these documents. Yes, and these documents typically executed here on the server, and what they generated was actual just plain old HTML. So on the browser would only ever receive just only HTML. Okay, only HTML. It was not. The browser was never aware that this HTML had been dynamically calculated. Okay, had been dynamically generated on the server based off of maybe a zip code. Then you would get the weather for your particular zip code, right? And based on that, you would calculate what's the weather in your area, right? And you would generate different HTML for someone else in a different zip code. Yes, all right. So this was the model view controller kind of in the web arena. It kind of grew out of this technology, right? They would break up the application into three parts, right? The view, the controller, and the model. And the view was represented in these pages, right? In these PHP pages, JSPs, and whatnot. And they would typically calculate the content. Any events that were generated when you submit a form would be handled by a controller. The controller would take in your arguments from having submitted a form. It would modify the model. The model would be provided to the controller, and then the controller would then decide that you would display either one page or another page, depending on where you were navigating, right, or what data you were submitting. And then this would be rendered and sent over to the browser. Okay, and this was a very successful model for many years. Okay, up until maybe 8 years ago, maybe 8, 10 years ago, right? When Google and these folks started really starting to move a lot of these ideas onto the client. Move this over to the browser. All right. So what worked very well on what we call today maybe legacy web applications, right? A lot of those same ideas, we're taking those and says, hey, can we apply those same ideas here on the browser? Yes. Downsides? Well, so that's it. That's the example that I mentioned. Was it yesterday? It's kind of like the difference of comparing the old MapQuest versus the new Google Maps, right? You have exactly the same use cases. In both cases, you can in MapQuest, right? You press a button, the whole thing reloads. The map either zooms, pans right, pans left. You can zoom in, zoom out. You can search. You can render everything. As opposed to what the newer way of doing that is that you never reload the page, right? And you have a much better experience, user experience, where most of the content stays, right? But you only update what you need, only the small snippet of it, right? If on this page, every time there was a user interaction, a brand new page, or even the same page, a different version of the same page, would be re-rendered from scratch, right? So if you had a very complex page, even if you had to change a small piece of the small page, right, you had to throw away the entire page and re-render it brand new. Okay, that's quite a bit of waste of content, right? That and all your references, all your images, all your links to other CSS and whatnot, all those would be presumably had to be re-rendered again. Right? Obviously, the browsers do a lot of optimization and cache a lot of that content, right? But it's a very jarring experience having to throw away the entire page, even if you just have to render a small snippet of it, right? So that changed about 10 years ago when folks started to demand the kind of experience they were having on desktop applications. On desktop applications, you have the whole application just catering to you, right? It only has to have to handle you as a user. You're the only user interacting with the desktop application, yes? As opposed to a web application, right? This server is not only interacting with you, but it's interacting with hundreds, thousands of users, right? Everyone's sending their own queries, and it needs to know that, oh, I'm going to send you that, and I'm going to send you this, right? It just sends different responses to different users, yes? So it's a very different problem of having to deal and interact with thousands of users as opposed to just a desktop application where it's only handling your input, yes? So on a desktop application, you could be much more responsive, right? You can, if you start dragging and clicking, and the experience is so much better, right? Because I only have to deal with you, and so you have these powerful word processors and spreadsheets and PowerPoint and all the applications, CRMs and project management applications that deal just with you. And people were saying, well, why do the versions in web are just so much clunky? Why are they so much? It's like walking through molasses. Everything's so slow. Everything has to be-rendered. So people were demanding the same kind of experience that they had in desktop applications that they were. They wanted the same kind of experience in desktop applications that they wanted for their web counterpart. So these folks started saying, well, what if instead of having the view rendered here on the server side, can we move some of this stuff over to the client and render it here instead of using these Java or PHP or Visual Basic running on the server? Can we maybe use JavaScript running here on the client? It's already here, right? It can manipulate the DOM, right? It can render content dynamically. Can we move a lot of this stuff over? Right? Can we move the view out of here, right, and move it over here so that we have rendering? Obviously, I don't have any data. I need to go to the server to fetch all this data, right? The client has no data. The browser has no data. The data is still here. It's way out here. So these folks say, well, this could give us an option where you render most of the page. You render most of the page. But if you want to update this small piece, it's okay. I can dynamically go fetch the data to the server, come back with a JSON data, right, and then just remove that and substitute it with a different piece of content without throwing away the entire document. Yes? Right? And that's where Ajax was born, right? Ajax is the technology that allowed us to do this, right? To be able to programmatically from the JavaScript, say, let me go fetch something, right? I don't need to re-render the page, right? And then I can dynamically just tweak a little piece of the page. Make sense? Right? This proved to be very, very successful, right? As Google has proved. Right, that all their applications work this way, right? All their content is dynamically rendered on the browser, and this began a new era of how to build applications, and so lots and lots of libraries started to come up to support the complexity of these applications, right? That they were growing in complexity. And says, why don't these folks on the server side have solved a lot of these complexities? Can we borrow a lot of those ideas that they've invented and they've proven very successful, very mature? They're tested. Can we copy some of these model view controller ideas, right, and bring them over to the client? And hence now you have lots of libraries out there that take the same breakup of the applications and again break it up into these snippets, right? Where you have the view, you have the controller, the model, and maybe a separate layer, an additional layer here, a separate layer, the service layer. Okay. Right, so here, again, you have the model. You might have the controller state over here on the server, but the controller started to change a little bit here. The controller wasn't handling user interaction anymore because all the user interaction was happening on the client, right? There was no user interaction here anymore, right? The only thing that the controller was doing now was just responding to requests for data only. Right? It never got any user clicks or drags or form submissions or anything like that. So it became kind of the sister or the mirror image of this service layer. Okay? So now the architecture looks something like this, where on the browser you have users interacting with the view. The view still has the same exact role, right? The same concerns of laying out the page, of looking pretty, and providing input fields. The controller still has the same role, but they're implemented into different language, in different libraries, and it's running on the browser as opposed to running on the server now, right? But it's same role, right? Making sense out of the events generated by the controller. Typically here, the model. This will be a snippet or a small subset, a very, very small subset of what the model might be here on the server. Right? On the server, you have full access to the database. You have full access to the entire data set. Here, you only have a small subset of that, only enough for you to be able to render something on the screen. Okay? This might be maybe you're going through a really long list of products, yes, and that list of products might be thousands of products, okay. Whereas over here you might be only looking at 10 products at a time, yes, and then you just paginate, 10 after 10 after 10. So this might be a small subset, right, of what the data model might be, okay. Also, it might be that over here your data model might be optimized of how you want to render it. Typically, this is a very flat data model, right? Whereas this data model might be, very hierarchical. You might have objects containing other objects, containing arrays of objects. Very, very normalized, very complex data model, right? Whereas over here, you might have a much flatter data model, right? And typically, in this layer, you might do a conversion. You might do a query, and then you might flatten it out enough that you can use it for rendering. And then you have a service layer, and that is the responsibility of fetching the data or sending the data to the server, and then the server just responding with data. Okay. Again, these are buckets that have very, very specific roles to play. Okay. Typically, these roles are based on living at the edge between two worlds. Right. Notice that the view lives between the edge of the human user, very slow, clicking every, hitting every keystroke, and the world of the object-oriented world, right? So it lives between those two different worlds, right? The controller kind of lives between an event world of interpreting a stream of events, right? And then representing that in some object-oriented representation, right? Or converting that into a stream of actions, right? Of function calls and into some kind of API. The model has the role of, again, having storing the actual data. The service lives between an edge of the object-oriented world representation and a stream world, right? This is HTTP. This is HTTP that needs to convert objects into some stream representation that needs to be sent over a wire. Yes, the service on the server side also lives in the edge, right? It needs to convert it back. It needs to convert from a stream world into some object representation, right? And then you have the model. Have an object representation of all the data, and typically you might have another a DAO here, whose representation is or a repository. We call this a repository, whose role is to do a conversion between a hierarchical Java object-oriented representation into a flat SQL relational database. Right? You need to be able to convert back and forth between these two worlds. All right? Again, the idea is that each one has its own complexities, each one has its own challenges, yes? And as human beings, we prefer to divide and conquer, right? And be able to say, okay, well, I know that I know this is the role of each one of these. All right, let me tackle each one of them, right? And this has been proven, to be a very scalable, a good way of breaking up large applications. Now, our application is not yet big enough to warrant such an architecture. Okay, nevertheless, as we grow bigger, as we add React and as we add Mongo and Node.js, and it will grow bigger, right? And it will warrant this kind of architecture. Okay, that makes sense. All right. All right, just a little bit of architectural discussions.